Hi guys, BuildZoid here, and we're back with the Biostar B550 GTQ motherboard. It doesn't suck anymore. Yeah, this is the final iteration. I've now implemented the power bridge. I've also added some extra heat sinks to the VRM well, yeah, I've added some extra heat sinks to the board. Yeah, now we can actually run Prime 95 indefinitely with with maxed out PBO limits. So here we are. This is Prime 95 128 KFFT size. And if you look at the VRM temperature over there, that's the VRM temperature sensor. We're now sitting at 87 degrees. Earlier it peaked at like 90. CPU pulling 225 watts according to the software, which is what it should be pulling at these settings. The PBO settings right now are 333, 222, 222. Which, yeah, that should be pulling about 220 watts. So, yeah, we can actually run maxed out PBO on this board now, which previously was just impossible. Even with a fan, you couldn't do this because it would just keep climbing in temperature. Mind you, I'm also using a smaller fan than I've used in the past when testing this board. So this is like, and this isn't even one of the, fun fact, this AMD stock cooler fan comes in two variants. One of them is much higher RPM than the other. This is the slower one. So this is actually, the current configuration here, the VRM cooling fan is actually quieter than the CPU cooling system, which is a good thing, because previously when I was testing the motherboard, I was using this thing right here. And this thing goes much faster, moves way more air, and is also significantly louder than the CPU cooling system. So at this point, it's kind of like, I mean, you know, we do still need to force some airflow over the VRM heatsink, but at this point, it's like a viable motherboard for a 3950X, because before the power bridge modification that is now currently on the back of the board, even this fan couldn't get it to run Prime 95, because as I said in the PCB breakdown, there's sort of two design flaws with this motherboard. One, the inductors that Biostar used are anemic little, you know, this is the kind of thing you would use for like a 5-volt rail on a GPU. Not a main power rail, right? The tiny little inductors. So in the previous video, I replaced all of the inductors, and that made it possible to run 233177 PBO limits, but you still couldn't run 333222222 because if you did that, the board would just overheat, or if you disabled the over temperature protection, it would just keep climbing in temperature, because the other flaw is the power plane on this thing. The power plane on this thing is garbage. It's very, I don't know how big it is, but it can't be very big because 4-layer PCB. And yeah, so we've got one layer of power plane in this, you know, and it's a layer down from the top of the board. Yeah, what would basically happen in the stock power without the power bridge, what would basically happen is the current flowing through the power plane would heat up the power plane, which would increase the resistance of the power plane, which would lead to the power plane being even less efficient, producing more heat, producing a higher I'm pretty sure if I wasn't stopping the tests at 105 degrees, the board might have been able to go full thermal runaway, as in the power plane would have just kept getting hotter and hotter and hotter until either there'd be so much voltage loss that it would crash, or the board would destroy itself. One of the two. And I didn't really want to I didn't really want to, dodgy power plane potentially destroying my 3950X, so I did not do that. So yeah, now we can run unlimited PBO, so that's pretty cool. Also, we're going to do a test of the voltage loss on the board now. It should be way lower than it used to be, which I've just realized I have no idea where I put my multimeter, so I'm going to have to go find that. And we're also going to turn this off and switch over from PBO to a static overclock because, yeah, but anyway, this is awesome. We can now run unlimited PBO as long as you have some amount of airflow over the VRM. So shut it down, and I'm going to go find the multimeter, and then we're going to put the board sideways and we can get some measurements from the back. We're not going to measure the capacitors in the socket anymore because that's where the power bridge ends, and that's just going to throw off the measurement inside the socket. I'm not sure that it's going to throw it off a lot, but I don't really want to go for it. Now, how do I... Man, I've really done it this time. Like, my multimeter is huge, and I've somehow managed to make it just disappear. Okay, well, looks like I'm going to have to go have a look around the room. It was in the kitchen. Why it was in the kitchen, I have no idea. That's not usually where I put it. But anyway, so yeah, we're going to be putting the board sideways. I'm going to also switch it over to the main monitor because I really don't need the like capture card getting in the way of me being able to do this. So turn off the power supply for a bit because what we're going to have to do is we're going to have to put the board sideways so I can get at the back of the PCB while it's running. I don't really have like... I think I do have the components necessary to build something so that we could put the board like full on upside down, but yeah, I've not set that up, so we are just going to go with the very fun option of just trusting the AIO to support the board from tipping over. Yeah. I will say the I/O cover that this motherboard comes with does have one benefit to it. When putting the board sideways, it acts as a really good like stabilizer because it's flush with the edge of the motherboard. So right now that's going to be... I remove all of the hold downs. Yep. Okay. Oops. Okay, right. We're going to have to pull the HDMI cable for this. I hate 24 pins. There we go. Board's sideways. You can just about see the capacitors hanging out on the back. So yeah, I'm going to be measuring against those, and it's reasonably steady. So yeah, let's do... I do this way too often. Like, technically, I could do this in a... Well, no, there's not enough space on this desk to put it in a case, but yeah, technically putting, like, if I had more space, then doing this with the help of a case would definitely be a, you know, better way of doing this. But, yeah, so we're going to power this up right now. I turned off the power. Power it up. I'm going to set the CPU to 4 gigahertz and 1.25 volts. Hopefully the BIOS hasn't decided to derp out, because that is an issue with this motherboard where on a cold boot, it just sometimes doesn't want to boot. Just Biostar things. I think it's doing it. I shouldn't have turned off the power supply. Oh boy. Yeah. Oh no, it booted. Okay, it's still figured out how to train the memory. Also, multimeter. Yeah, we can just about fit the multimeter in the shot. That's the main thing I wanted. Also, what's nice about the new configuration of the motherboard, like previously when I was doing this test, the VRM would rocket up in temperature, like scream its way towards 90 degrees. So I really didn't have much time to take my measurements, which made it really just annoying to deal with. Actually, I don't need to change the PBO settings because that just gets overridden when you do manual overclocking. So we're going to set this to 4 gigahertz, level 4 LLC, and a CPU core voltage of 1.25 volts. So, yeah, and previously, I'm going to have to pull up the notes I have from the previous testing because I do not remember. But that's fine, because the board is booting up right now. Where is it? Oh, right, it's under AM4. Okay, so previously, the capacitor nearest to the CPU socket would be at 1.38 volts, and the capacitor furthest away from the CPU socket would be at 1.427 volts while running Cinebench. So we're just going to run Cinebench, and I do realize you guys can't see Cinebench running, but it's not the point here. You're just going to have to take my word for it, I guess. Like, I don't really have a good reason to lie to you, do I? Man, I've just made myself sound really, really sketchy. Okay, you know what? Screw it. We're going over to the capture card. Actually, that HDMI cable is arguably better suited to the motherboard being sideways. Man, I hate doing that so much with a board like this. It's not working. Why is it not working? Work. Oh no. Yep. This is why I didn't want to use the capture card. Oh, don't tell me I crashed it. I mean, that wouldn't really surprise me. You shouldn't be doing this like that. Okay, we're going to switch back to the other HDMI cable. Okay, no, the capture card's just being completely bloody stupid. There's nothing I could... why now? Why now? Of all the times to just completely fail, why now? You stupid pile of trash. Anyway, so yeah, the capture card has decided that it's like it's just not going to cooperate with us. I hate my I like my multimeter. I hate my personal system. Anyway, actually no, I don't. Like I just hate the capture card part of it. Okay, so need to run some Cinebench. Also, I'm going to get hardware info up so that I can actually see the VRM temperatures. Yeah. Would be a bit better if you could see Cinebench, but yeah, you'll just have to take my word for it. So core voltage currently it's at 1.25 because we're not running anything. I hit run and the core voltage should drop to about 1.2 volts. And it does? Yeah, it does that? Okay. So let's measure the Vcore capacitor. There's a bunch of flux in the way and my probes aren't super sharp. Yeah, so that's at 1.33 volts right now. Now, the voltage floats around a little bit because obviously Cinebench load cycles. So when you see the render start over, the voltage will drop. So render finished, voltage drops, and then it ramps back up. But that is a huge improvement. Like, this capacitor right at the bottom of the board previously, running Cinebench like this would be at 1.427. It is now at 1.33. You know? It's at 1.33 now instead of... Like, that's 100 millivolts less power loss. So, that's pretty good. It's pretty good, I'd say. Now we're going to measure the... Actually, wait. Yeah, now we're going to measure the near capacitor. Which I'm really not sure what to expect over there. And we're getting 1.3. So yeah, just across the board, less of a difference, because I think... so this one's less of an improvement. This one was previously 1.38 volts, now it's at 1.31. But like now we have like the whole VRM is actually sitting at a more consistent voltage just across the board. So that's a huge improvement. Like previously, the faraway capacitor was 1.427 volts. And the nearby capacitor was 1.38, and now we're getting 1.33 and 1.31. So that's a huge improvement. Because the thing is, I didn't just run power bridges to the socket, I also ran little pieces of wire from each capacitor leg to the next capacitor leg, so that we wouldn't have like... Because previously, there was just a huge difference across like the VRM port, like just from like the far away phase to the near phase. There was a huge drop in voltage between the two of them. So, you know, I sort of figured out like... So I figured with my modifications, like I actually want the voltage to be relatively even across even just the output of the VRM itself. I'm not sure if that's necessary, but it certainly doesn't hurt. Like the less of a voltage difference there is between any points in the power plane, the less power loss there is in the power plane, and also now in the power bridge itself, right? The power bridge obviously is losing voltage. Yeah, we're not going to measure the power bridges. The soldering's kind of screwed up the measure points. So yeah, Cinebench is happily running right now. So we're just going to stop Cinebench. Now we're going to run Prime 95, the trial by fire. So previously, Prime 95 would shoot up to 1.53 volts on the faraway capacitor. I'm still opening it. And now, I mean, I'm expecting it to just kind of sit at like... honestly, I think we might be under 1.4. I'm not sure. But I'd be happy if it was under 1.4. It probably will be, because well, I don't know. I really don't know. Because previously the difference between Cinebench and Prime 95 on the faraway capacitor was 100 millivolts. So if it's still 100 millivolts, which I don't, like, it shouldn't be, then right now we should be seeing 1.43 volts. But I think we're going to see more like I'm hoping for like 1.39, you know, to be under 1.4. Yeah, anyway, so let's start. So Prime 95 is now running. Yep. CPU is hitting 80 degrees, about 1.2 volts core voltage, which is correct. And now let's get our probes in there. We are getting 1.38. Nice. That's very nice. That's great. That's such a massive improvement. That's 150 millivolts, less power loss. And now, the nearby capacitor, 1.34. Yeah. So basically what we can see from this, I think there's still like quite a lot of resistance from the VRM to the actual CPU socket, but on the VRM itself, there's much less resistance, which makes sense. I put there's just less there's less distance that the wires need to cover in the VRM section of the board. Also, the board's currently at 84 degrees on the VRM. So previously doing this test, like at this point, it would have been tripping the over temperature protection. Like, I'm being really chill here with taking my measurements. When I was originally taking the measurements, I would basically have to wait for the board to cool down, start Prime 95, take the measurement, stop Prime 95, wait for the board to cool down again, start Prime 95, take the measurement, stop the Prime 95 again, which was just, like, horrible. Like, absolutely. And mind you, I had a fan on it. Right now, there's nothing really cooling the VRM other than, like, whatever the airflow from the radiator it's getting manages. So, yeah, huge improvement. Yeah, like, board, like, this is now, like, a halfway decent motherboard. The BIOS is still, you know, not particularly incredible. The memory overclocking is still, well, for this price point, I think it's about what you'd expect. I think, because this is one of the cheaper boards. The issue is, though, like, I don't really see this, well, no, in the stock configuration, this motherboard's just trash. And in this and in my, like, modified version, it's still kind of like, well, it doesn't try to set itself on fire anymore, but it still sucks. Like, it's still not really, like, at this point, I'd say, okay, it's usable, but it's not, like, it's not a good motherboard. It's just not, you know, dangerous it's not just going to destroy itself, which previously, like, honestly, even, like, a 5800X would have probably been a bit, like, would have been kind of pushing it, right? Like, because even the stock power limit on the 3950X, because we are testing with the 3950X here, not the 5950X, I would not put that CPU anywhere near this thing. The 3950X is a little bit more expendable, because worst case scenario, these days they go kind of cheap on eBay. So, yeah. And anyway, so that's the measurements. I'm just going to note them down into my document. So yeah, we're not going to do like the component, like previously I had measurements that were like for the different parts. Like for like how much loss was Vcore, how much loss is ground, but we can't do that anymore because the power bridge is in the way of taking those measurements, so we're not going to do that, but yeah, like I'm really happy with the improvement. Like that is a big improvement. So, shut it down and let's take a look at the modification. I mean, I've already shared a picture of the modification on the community tab, but it's going to be more interesting to take a look at it on video, and I can also talk a little bit about what went into it. So, let's turn this off. Okay, I do not actually want to... Yeah, because we've got wires hanging off the back of the socket, which... Come on, go. Like, I don't want to... Like, we can't really rest the board backside down anymore. I'm gonna have to put, like, some kind of standoffs on the motherboard to make sure that, like, the socket doesn't ever... Because if you push down on the wires now that are on the back of the socket, it's potentially going to damage the capacitors in the socket, which is just like, yeah, this is not a practical modification by any means. Well, I mean, if you put it into your PC, it actually wouldn't really be too much of an issue. Okay, you know what? We're getting a... Go. And... There. So yeah. So that, like, I'm not resting the board on its back while I take it apart. Come on. That 8-pin is really tight on this board. Oops. So, yeah, I also replaced the thermal pads on the heatsink, but honestly, like, I tested all of the heatsink modifications before doing the power bridge. They weren't enough. They really weren't enough, which makes sense, right? Because the power bridge isn't here to improve the efficiency of, like, the inductors or the power stages, which is what the heatsink is making. Like, the heatsink is making contact with the power stages, right? So the power bridge doesn't improve the efficiency of the power stages or the inductors. No, it's there to improve the efficiency of the power plane. And well, the power plane does not have a heatsink. There's like, the power plane starts after the inductors. So, you know, upgrading the cooling system like this is just not really going to do much for the power plane. Well, this heatsink right here is actually stuck to the power plane itself, but again, like, that's the top layer of the power plane, and I don't know how many vias, you know, Biostar is running. So if they don't have a lot of vias between the top, like, the top part of the Vcore power plane and the lower part of the Vcore power plane, then it's just like, the thermal resistance between the two layers is going to be pretty high. So putting a heatsink on the top layer is like, well, okay, your top layer is cold now, but your internal power, like, the thing that actually goes all the way to the socket, because the Vcore sort of polygon on top of the PCB, that one doesn't reach the socket. Like, that stops well before the socket. There's a bunch of signal traces in between it and the CPU socket. So, yeah, that one, you know, doesn't really... Go with my CPU, please. Oh boy. Man, MX4 is glue. Oh. Did I forget? No, I did not forget a screw. Just doesn't want to let go. I really thought the chip was coming out with this one. But we made it. Like, the thing with, if you're pulling on an AMD CPU and you're worried that you're going to pull it out of the socket, pull straight up. Pull straight up. Do not pull at an angle, because if you pull it at an angle, you're going to bend all of the pins on the way out. Ask me how I know. So, don't ask. Like, it's pretty obvious. I once had the genius idea of, like, tilting an LN2 pot off of an AMD CPU. Had to realign 2 whole rows of pins. Now, luckily, they were all bent by the same amount, so it was pretty easy to make them straight again, but, you know, not really what you want to be doing if you can avoid it. So, here we have the board. I mean, you've seen the capacitor situation on the front before. Now, I also, in the original modifications of this motherboard, I actually ran a wire between some of the inductors on the top side of the board, just to try reduce the like, because when I first got the board, like, there was a big difference in voltage between, like, here and here on the power plane. So, you know, just running a little wire to try reduce the resistance just between the different inductors on the top layer. And then we get to the back of the board where we have the very heavy modifications. Well, heavy modifications. So, there we go. I'm going to zoom in on that. Also got to rearrange my thing. Go. So pretty simple what's going on. Let's get an implement of pointing. So each of these, well, okay, so there's this big fat wire. So that's an 18 gauge like power supply style wire, and I just have a bunch of that spare, so I decided to use one of those. And then these smaller wires, those are 22 gauge solid core, like single core wires. And there is 6 of them. 1, 2, 3, no, 5. Yeah, so there's 5 of those. There's one 18 gauge, and yeah, that's all you need to knock like previously this capacitor would be hitting 1.53 volts. With this power bridge, it hits it now hits, let's pull up those, what was it? For Cinebench it was 1.33. Wasn't it? And Prime 95 it's now at 1.38. Right? So absolutely gigantic improvement. Like this cap has just so much less, like the difference in voltage between this capacitor and like, well, at this point we're not comparing against the back of the socket, because the thing is, this is where the power bridge ends. So if I try to measure with the multimeter over here, it's going to be skewed by the power bridges. So like the difference, if like I actually measured in the socket, the difference would be smaller. So we're not, I didn't do that. But yeah, just like compared to the previous configuration, this cap is so much closer to the final core voltage, right? Because the core voltage in both scenarios, like both scenarios, we were running 4 gigahertz, 1.25 volts level 4 LLC. And yeah, the chip was actually like much closer to the final load voltage of the CPU, thanks to the power bridge. So this cap saw a huge improvement. This one, not as much of it. Well, still like 100 millivolts basically on Prime 95, and like, because previously it would hit 1.45, now it hits 1.35, and the Cinebench R20 test, it hits 1.31 instead of 1.38. So yeah, huge improvement right there. And all you need to do is run a few wires. Now, this is the half-assed version of the modification. And the reason why it's the half-assed version of the modification is because I just went over the CPU backplate. So this backplate is not coming off anymore unless you're going to like desolder all of these wires, which I'm lazy. I'm not doing that. So yeah, this is and also like this also makes the board impractical. Like you can't put the board down flat, because these wires are potentially like, if you put the, like, potentially it could break in the connection behind the socket. Or, well, no, I'm not fussed about this point. There's not really, yeah, like this area I'm not too worried about. This right here, very concerning. So yeah, you can't put the board down properly anymore. The backplate doesn't come off, so that's sort of the things, because I have other boards where I've done power bridges like this. I have a 990FX board where I've done this because it's 990FX, and guess what? A lot of 990FX boards use 4-layer PCBs. I don't think any of them are as bad as this, though. That, now that I think of it, that is probably that would be something interesting to check. To check, wouldn't it? The thing is, the power bridged board is covered in Plastidip, so we're not, like, I don't feel like taking off the Plastidip. It's prepped for LN2. And then my other 990FX board is also prepped for LN2, and I haven't removed that Plastidip for like years. I'm not about to remove it now. I'm pretty happy with the fact that with how it's been holding up. So, yeah, but I do have a different B550 motherboard that also uses a 4-layer PCB that doesn't have VRM thermal issues, but it would be interesting to see how much power loss that has, or just to have a comparison of like a good 4-layer motherboard versus a terrible 4-layer motherboard. Yeah, and then so also you can see the little like small wires connecting each of the capacitors together. This is just to minimize the difference between like the top cap and this bottom one. And yeah. Oh, and I guess, so what's cool about this power bridge mod, especially in this scenario, and why it's so ridiculously effective, or at least why it looks so ridiculously effective, I don't know, I would consider this insanely effective. Like, I've tried to do power bridges on GPUs in the past, and you'd be lucky to knock off like 10 millivolts or something, and here it's just like hundreds of millivolts. I mean, well, not hundreds, but 150 millivolts on the, you know, far away capacitor. And the thing is, there's sort of two benefits to this. Or like, the benefits of doing this sort of stack on top of each other. So the initial benefit is like, okay, the power plane now has less resistance, right? Because there's just more copper connecting the output of the VRM to the CPU socket. So there's less resistance. Nice and simple. However, there's the second benefit is that now that there's less resistance inside the actual PCB, right? Like, or well, okay, no, the resistance inside the PCB is still the same, but because there's less current that flows through the PCB itself, and more of it flows through and while some of the current has the option to take the power bridge instead, the internal power plane doesn't get as hot. So if the internal power plane doesn't get as hot, and it's made of copper, right? And copper gets higher and higher in resistance as it gets hot. So since there's less current flowing through the internal power plane, and it's getting it's producing less heat, and so its operating temperature is lower, so its resistance is also lower, which further improves the means basically your resistance is again lower because it's also cooler. So it's not just like the act of just adding the extra copper itself sort of has the effect sort of stacks, where you just have less resistance, therefore less heat output, which translates to lower operating temperature, which leads to slightly less resistance again. Because the thing is, previously, the power plane, as it got hotter and hotter and hotter, it kind of looked like it would want a thermal runaway eventually. And so I'm guessing that's why the motherboard's over temperature protection is so low. Because this, 95 degrees Celsius over temperature protection is really low. Like, in my opinion, a reasonable over temperature protection for a well-designed motherboard is over 100 degrees. So Gigabyte usually sets it to 120, 115, and I think that's a totally reasonable over temperature level. For a VRM. And then there's this board which has it set to 95, and it's just I guess because the thing is, the VRM temperature is not going to be reflective of the power plane temperature, right? Because the power plane's, from this side of the board, it's 2 layers down, because we have the top layer here, which is primarily signaling, and then there's a layer below that, which I'm guessing is ground, and then there's another layer, and then the layer after that is the power plane. And that's probably going to be a triangle that basically goes between here and here. And honestly, that might be giving it too much credit. It might be it might be worse than that. It could shrink down and then just be a little rectangle going under the socket. But I don't know. I don't have the schematics for the board. So, yeah. So the VRM being at 95 degrees doesn't really tell you, is the power plane at 100? Is it at 110? Who knows? There's no temperature sensor embedded into the PCB, and you can't measure it from the top layer of the PCB because, well, it's the top layer of the PCB. It's not actually the power plane, right? So, yeah. Garbage motherboard. Fun modification. I love doing this kind of thing. I love it even more when it works really well. Honestly, I've done power bridges before. I've done them on the 990FX board. I didn't do a before and after. I just kind of went for it's a 4-layer board. It's going to help. I don't know how much it helped, but it's going to help. And that one wasn't wires. That was actually copper foil and then a bit of copper plate mixed into the foil as well. So that one was really fancy, and I snuck it under the socket, and then I still had to have O-rings to raise the back. I snuck it under the back plate, but the back plate still had to be raised off, because if I just used the foil, you could have just run it would have been fine. But then I was yeah, but we could also put a plate on top of the foil. More copper, more better. And then it was well, now it doesn't fit under the. Now it didn't fit under the back plate anymore. So. Yeah, but still, so I kind of wish I had measured that board, but here we have an actual measured one, and yeah, it works great. I think this video is now getting unnecessarily long, but I'm just excited about this, I don't know, kind of exceeding my expectations. I did some math on paper. This technically should be, on paper, this should be about, almost the same cross-section, these wires right here, because they look really insignificant, but on paper they should actually be pretty similar in cross-section to the power plane at this point, right at the VRM. I don't think the power plane is a big fat rectangle. I'm pretty sure it's a triangle, so it actually thins out as it approaches the center of the socket. And the thing is, so because what you have to consider is I'm as far as I know, Biostar does use 2-ounce copper PCBs, or at least they advertise it. I'm pretty sure I saw them advertising that they use 2-ounce copper PCBs. So that means the ground layer and the power layer are going to be 70 micron thick. So yeah, but that's like, that's like 0.07 millimeters by this right here is like 44 millimeters. So the cross section right here is only like, I think 3 millimeters square or something off the top of my head. These wires combined are like 2 millimeters square. So I guess it makes sense that we saw such a huge voltage improvement. Because then there's also the added on effect of like, well, now the power plane isn't trying to set itself on fire anymore, so it has even less resistance. But yeah, anyway, at this point I'm just rambling, so we should just end the video. Yeah, hopefully you found this interesting. I found it fun to do this kind of thing, like especially since I decided to just half-ass it instead of like being super fiddly about getting it to fit properly. It's just kind of like, well, it works. The board's kind of unusable now, but it works. So yeah, that's it. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store, where you can buy, shirts, stickers, posters. I think there's hoodies, there's socks, the usual, the usual YouTuber merch. The Patreon and Teespring help out immensely with running the channel. Like how do you think, well, I mean, just the soldering equipment for that, the board, actually the 3950X. Yeah, that's my 3950X. Well, my Patreon supported 3950X, but for all intents and purposes, my 3950X. It's not like it belongs to some manufacturer. Yeah, it would be much appreciated if you check out the links in the description. And that's it for the video. Thanks for watching, and goodbye.